Now let us to discuss the one more problem in the principle of mathematical induction. This is very important, you people. So in this problem, what I am doing, we are going to prove 1 by 1 into 5 plus 1 by 5 into 9 plus 1 by 9 into 13 plus so on up to n number of terms are there. The sum it is equal to n by 4n plus 1. So mathematically we can find the sum of these all the terms, all the fractions up to the n terms equal to n by 4n plus 1. But instead of finding its sum, now we are going to prove this statement it is true for every natural value of small n. For that one, already we discussed in the last class. First, whatever the statement given to us, we need to assume it as p of n. So let p of n it is such that 1 by 1 into 5 plus 1 by 5 into 9 plus 1 by 9 into 13 plus so on up to the n terms is equal to n by 4n plus 1. So now here this is just a different problem. In this series, in the LHS part, we don't know the what is its nth term. So for that one we need to consider the every term separately. So in the above statement we don't know the nth term of LHS. Then first we need to find its nth term. What is the nth term of it? So for that one, and just to go through the all the terms, I think in all the terms the numerators are the same 1 1 1. That means in its nth term also the numerator will be the 1. So we can understand the numerator of nth term of the this series. So now go to the denominators. So in the every term in the denominators we have the two factors are there, right? So that means in the nth term of its sequence also we should have the two terms here. So now let us to go to consider only the denominator parts here. Look here carefully, only the denominators and every denominator it is in the every term every denominator it is consisting of two factors, like in the first term 1 and 5, in the second term 5 and 9, in the third term 9 and 13 are there. So just we need to take only the first factors of the denominators of every term. So in the first term the first factor it is 1, in the second term the first factor in the denominator part it is 5, that is in the third term it is 9. So just go to consider only the first factors 1 5 9. So I am writing that all the first factors of denominators of all the terms of the LHS 1 5 9 so on. I think these numbers are increasing by 4. That's why they are in the arithmetic progression. So now I want to find the nth term of these all the first factors. For that one, we'll use the nth term of arithmetic progression formula. That is Tn is equal to a plus n minus 1 into d. So whereas a is the first term of the progression, that is 1, and d it is a common difference of this progression. It is nothing but t2 minus t1, 5 minus 1, it will be the 4. So using the Tn formula, you will get a it is 1 plus n minus 1 into d it is 4. Now multiplying by 4 here, this will become 4n, and 4 into 1 minus 1 it is minus 4, and at the plus 1 it is there. So simplifying them, you will get nth term of it is 4n minus 3. That means here for the first factors their nth term it is that 4n minus 3, we got it. So similarly we will go to consider the second factors of all the denominators of the given statement. So here 5 9 13, that they are the second factors, and we will write second factors, and I think here again these second factors also in the arithmetic progression. So then we should consider the first term, the value of 8 is 5, and the common difference is t2 minus t1, 9 minus 5 it will be the 4. Then we use the nth term of arithmetic progression formula, that is a plus n minus 1 into d. So using it we can find the nth term of it, substituting the values of a and d here. So a it is here the 5 plus n minus 1 into d it is 4, and 5 will come same as it is, 4 into n it is 4n, and 4 into minus 1 is minus 4. 5 minus 4 that is plus 1. So you will get only the term 4n plus 1. So here This is the nth term of the second factors. This is the nth term of the first factors of the denominators of the every term. Now, I want to my aim to find only the nth term of this given series first now. So, in the nth term, we consider we understood that in the nth term also the numerator must be the 1. So then we write that nth term of the given statement as 1 by, we should have the two factors in every term now. So that's why the nth term of the first factors it is that 4n minus 3. Nth term of the second factors it is that 4n plus 1. So we need to take this both the terms product here. So then 1 by 4n minus 3 into 4n plus 1 will be the nth term of the given statement. So now again I am rewriting the statement p of n. Then we write p of n is such that 1 by 1 into 5 plus 1 by 5 into 9 plus 1 by 9 into 13 plus we are going to write here the nth term of it, that is this one. We will add it here, the 1 by 4n minus 3 into 4n plus 1, then it to be is equal to n by 4n plus 1. We should write that one. Now from here, so after getting that the nth term of this statement, now we'll go to use the principle of mathematical induction. So already we discussed about it. Now we will verify the truthfulness of this statement. Is it true for the value of n equal to 1 or not? If I write n equal to 1 means in this expression n equal to 1 means so I said that will represent only the first term of this progression. So this is 1 by 1 into 5 will come. First term of this series 1 by 1 into 5. Then here the writing n equal to 1 here, 1 by 4 into 1 plus 1, 1 by 4 into 1 plus 1. Then finally we get 1 by 5 equal to 1 by 5, which is true. That means p of n equal to 1, it is verified true. So we have successfully completed the verification of p of statement. It is true for the value of n equal to 1. Now then we should do. Now we already proved p of n equal to 1, it is true. So in the principle of mathematical induction, we need to assume p of n equal to m, it is again true. So for that one, then if p of n equal to m it is true, we write the statement as 1 by 1 into 5 plus 1 by 5 into 9 plus 1 by 9 into 13 plus so on. Wherever the n, we should write there yet m here. So in the last page we have here the nth term, it is there for 1 by 4n minus 3 into 4n plus 1. So there we need to write here the m. Wherever the n, write there m there. So then finally we will get this statement. So it's very clear to you people. So this is our assumption only. So now what we do in this principle of mathematical induction, we will try to prove this statement is again true for n equal to m plus 1, the next term of it. So now I think here we have m number of terms are there. Now we need to guess what will be the its next term. So for that term we need to add it to both the sides. So that is very important, you people. What the term should we add to the both the sides to it? So this is as it is I am writing here, and till here I am writing as it is. Now but I am adding this term to the both the sides. Why? Because it is the next term of it. How it will come means, just consider the first factors 1, 5, 9. They are increasing by 4. So that means in the next term also the first factor will be in the denominator. That is for more than this term. So 4m minus 3 plus 4, that is 4m plus 1 will come. So like that the second factors also in the same manner 5, 9, 13 so on 4m plus 1. Then adding 4 to 8 you will get 4m plus 5. So then this will be becomes the next term of it, the term we are adding to the both the sets of this statement. So adding it, you will write like this whole the thing plus this one will come on the right hand side, m by 4m plus 1 plus again this we should write. Now what do we do? This is very important, you people to observe. Now this RHS part, try to express, simplify it and try to express this is in the form of n by 4m plus 1. For that one, so whenever you are simplifying this RHS part, please try to take the common factor outside of it. So I think in the denominator we have 4m plus 1, it is a common to in the both the fractions. So taking it as common in the denominator part, so numerator there is no common factors, that is one only common, it is to the both the terms. So now I need to take 1 by 4m plus 1 as common. After taking 1 by 4m plus 1 common, so we should have m by 1 plus, and the remaining term will be the 1 by 4m plus 5 will come. Now simplify this both the fractions. You know that LCM of this both of them is 4m plus 5, and multiply like this. M into 4m plus 5 will come plus, and 1 into 1 it is 1. Now after multiplying this term, factor will come as it is in the every step, and m into 4m it is 4m square plus m into 5 it is 5m plus 1 it is there. So you know very well, and here we are getting a quadratic expression. We will try to write its factors like this, and in this both the factors, I think this m plus 1 it already we have taken that 1 by m plus 1 as common. So in the denominator part m plus 1 it is there, so this part will definitely will come here, so that both will get cancelled in the every problem. If it is in this form, then we'll get m plus 1 by 4m plus 5. So our aim to prove it in the express it in the form of the RHS of given statement. So this is m plus 1 it is there, write it m plus 1. Now I want to write this whole expression in terms of m plus 1 only. So numerator is m plus 1. So I want to write this one also in the m plus 1 term. So then 4 into m plus 1 I am writing. 4 into m plus 1 will becomes 4m plus 4 will come. But it to be 5. So for that one we need to add one more to it. So 4m will come same. 4 1 is 4 plus 1 it is 5. So like that we can express. I think clearly this the last statement it is in the form of n by 4n plus 1, isn't it? So that is our required to prove. So that means we proved that p of n equal to m plus 1 it is also true. So according to the principle of mathematical induction, whenever p of n equal 1 it is proved true, p of n it is true, p of n equal to m is also true, which implies p of n equal to m plus 1 it is again true. Then we conclude that it is true for every natural value of small n. So it's I hope this problem it is very important to you people. I hope you people understood it very clearly. So using these 4 or 5 videos are there I kept in the principle of mathematical induction. Using them you can do the remaining more problems in the same manner only. If it is clear to you, please like it and subscribe my channel, and we will go to discuss another topics in the next videos. Thanking you. Bye.